Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, The Official Guide to the Revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 126. Please turn to it. Page 126, problem number 5. The problem number 5 that you see there on page number 126 is actually the problem that we did day before yesterday on day 260. And then yesterday we did one more problem, second problem in the series of 5, the work problem. Yesterday we did one, and today we're going to do the third one, which is a very similar problem to what you see there on page number 126. And as I said, we're going to do a series of 5 of them. Today is the third one. So here's the problem. We are told, so this problem actually is not in the book, it's the bonus problem, as you can see. We are told that A can do a job in 3 hours. We are also told that B can do the same job in 5 hours. Question is, how long will they take together to do the job, working at their respective paces rather, actually working together. So let's do it. Here are the answer choices. 8/15, 1 7/8, 2 1/2, 4 and 8. 4 and 8. Or if you like, we could. Okay, this is good enough. Well, there are two ways we can go about it. One way is what, if you watched the previous two videos, you know, one way is what we call the quick and dirty way, where we ask ourselves, what is the possible range here for correct answer to fall in. Determine that range. Ask yourself, how long will it take? How long will it take for them to do the job together? If both work as slow as the slow guy, job will take how long? If both of them work as slow as the slow guy. Well, slow guy, we are told, takes 5 hours. So if you had two guys working at the exact same pace, 5 hours for the job, if one guy takes 5 hours to do the job, the other guy also takes 5 hours to do the job, if you put them together, they should be able to do the job in 2.5 hours. Similarly, if both work as fast as the fast guy, job should take how long? But the fast guy, we are told, can do the job in 3 hours. If we have one guy who can do the job in 3 hours, and then if we have another guy who can do the job also in 3 hours, if you put them together, logic dictates that they should be able to do the job together in 1.5 hours. That's our upper and lower bounds. So that's the very first thing you should think about. Of course, we don't have to write everything down. You have to think logically and ask yourself, what is your upper and lower bound? And you will find that almost always you will be able to knock out two or three answer choices. Not necessarily 4 of them, obviously, but you should be able to knock out at least 2 or 3 answer choices. Those are the impossible answers. And at that point, if you don't have the time or if you don't know what else to do, just pick one from the remaining 2 or 3 answer choices and move on. That's it. At least you have a better odds of picking the right answer. So let's see what we can do here. So the correct answer, whatever it is, cannot be less than 1.5 hours. That's the best case scenario where both of them are working as fast as the fast guy, which we know is not the case. So it's going to be more than 1.5 hours. And also, it cannot be as long as 2.5 hours because we know both of them are not working as slow as the slow guy. So it's going to be somewhere between 1.5 hours and 2.5 hours. Let's see what we can knock out here. 8 is gone. 8 is too long. 4 is gone. It cannot be 2.5, and it cannot be less than 1.5 hours. It cannot be less than 1.5 hours. 1.5 hours is how long it will take if both of them work as fast as the fast guy. There you go. You're done. That's it. The answer is B. That's it. We're done. Now let's do it the classical way. The LCM method. In the classical way, what we ask ourselves, what we're looking for here, is the smallest possible number that you can think of that we can divide evenly by 3 and a 5. Well, obviously the smallest number will be 15. That was very straightforward. So ask yourself, what would happen if they both were to work for 15 hours? In 15 hours, we are told that A can do a job in 3 hours. If A can do one job in 3 hours, then A in 15 hours should be able to do, in 15 hours, A should be able to do how many jobs? Well, it takes 3 hours to do a job, so he should be able to do 5 jobs. Similarly, in 15 hours, B should be able to do how many jobs? We are told that B takes 5 hours to do a job. Well, if he takes 5 hours to do one job, well, in 15 hours, he should be able to do 3 jobs. There you go, we're almost there. So that tells us that together, they can do 8 jobs in 15 hours. Well, if they can do 8 jobs in 15 hours, they should be able to do one job. This implies that they should be able to do one job in an eighth of the amount, which is 15 over 8. Or, if you like, 1 7/8 hour. There you go. The answer is B, as we already knew before. That's it, we're done. As we move on, I'm not going to do number 4 and 5 in the series of the work problem. I'm not going to do them. I'm not going to do those two tomorrow. But when we get to page number, where can I stick it? Page 231. On page 231, 2.7.4, example 2.7.4 on page 231. When we get that far, we're going to do 2 more, number 4 and number 5 in the series of the work problem. Okay. Tomorrow we're going to pick up where we left off, which are the problems that you see beginning with page number 127. They have to do with percentage problems. We're going to do those tomorrow. All right. Bye now.